So guys, in this lecture we are going to study न्यूट्रलाइजेशन रिएक्शन। ये क्लास 10th का लेक्चर नंबर 6 है। चैप्टर हमारा चल रहा है एसिड्स बेसिस एंड सॉल्ट्स। इसमें हमने डिस्कस कर लिए हैं एसिड बेस के जो भी इंपॉर्टेंट कंसेप्ट्स हैं वो सब हमने डिस्कस कर लिए हैं, और प्रीवियस ईयर कॉम्पिटिटिव एग्जाम्स में जो भी क्वेश्चंस आए थे वो भी हमने डिस्कस कर लिए हैं। नाउ वी हैव टू स्टडी न्यूट्रलाइजेशन रिएक्शन एंड टाइप्स ऑफ सॉल्ट्स। नाउ व्हाट इज न्यूट्रलाइजेशन? Neutralization reaction is actually a reaction between acid and base. A reaction between acid and base. A reaction between acid and base. We take acid, we treat it with base. Whenever acid and base react, they form salt and we get water as a byproduct. Now this is neutralization reaction. Reaction between acid and base to form salt. Now what type of salt we are going to get? What type of acid reactors? What type of base reactors? What type of salt we are going to get? We are having different types of salts. We are having strong acid and strong base salt. When strong acid and strong base reactors. When strong acid and weak base reactors. When weak acid and strong base reactors. When weak acid and weak base reacts. Therefore we can have 4 different types of salts. Let us first take an example of this neutralization reaction. Let us take example of HCl and NaOH. Now see, we have shown that HCl is an acid because it donates proton. Now if the reaction happens, then what happens? This bond breaks. To which side this bond breaks? Towards more electronegative atom. Bond breaks towards this side. We get H positive and Cl negative. In this case, bond breaks towards OH. Why? Because sodium is a metal. Metals donate electrons. Metals do not accept electrons. Therefore, we get Na positive and OH negative. Now what happens? Now the reaction between ions takes place. This sodium positive reacts with this Cl negative. We get NaCl. This is our salt. And this OH negative attacks this H positive, we get water as a byproduct. This is the mechanism of the reaction. Now how can we say this salt has been obtained from which type of acid and which type of base? That is, whether it has been obtained from strong acid and strong base. Therefore we should have a concept of strong acids, strong bases, weak acids, weak bases. Now remember one thing, there are tricks for you how to remember which are strong acids and strong bases. Now strong bases for we people are strong bases are group first and group second hydroxides. Group second hydroxides. Strong acids, strong bases are group first and group second hydroxides. We have group first lithium, sodium, potassium, rubidium, cesium, and group second elements we have lithium, beryllium, magnesium, calcium, strontium, barium. Hydroxides of these groups: OH, lithium hydroxide, OH, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. And hydroxides of this: BeOH whole twice, Y twice because it is bivalent, MgOH whole twice, CaOH whole twice, SrOH whole twice, BaOH whole twice. Now these are all strong bases. Whatever base you have except these bases, they are weak bases. These are all strong bases. Remember these are group first hydroxides and group second hydroxides are strong bases. All bases except these are weak bases. Now how to remember strong and weak acids? There are certain acids which are weak acids, except those almost all acids are strong. I am using the word almost because there may be other examples as well. Now see, carboxylic acid, that is acetic acid. We have HF, hydrofluoric acid. We have HCN. We have H2CO3. These are examples of weak acids. These are examples of weak acids. These are examples of weak acids. Almost all other acids are strong acid. All other acids means we have H2SO4, it will be a strong acid. HNO3, strong acid. Now strong acids and strong bases 100% almost completely ionizes in aqueous solution. Weak acids dissociate or ionize to a less extent. Now, depending upon the formation of the salt, we can have four types of salts. This type of reaction is called a neutralization reaction. This reaction is exothermic. By exothermic, I mean that in this reaction, heat is released, that is delta H, enthalpy change for this reaction is negative. Enthalpy change for this reaction is negative. It is an exothermic reaction. How much amount of heat is released? It has been experimentally found when strong acid reacts with a strong base. When strong acid is neutralized by a strong base, an amount of 57.7 kilojoules per mole of energy is released, minus 57, or it is minus 13.7 kilocalories per mole. This is a constant quantity. It varies when we take what type of salt, what type of these acids and bases weak. In case of strong acids and bases, the value is same. Now, for this numerical part of this type of question is how the heat is released is this, how it can change. I upload the video in thermodynamics, that's heat of neutralization. You can watch that. Now, see, we have different types of salts. Now, the types of salts are, we have different types of salts. Either we have a salt types. Either we have a salt of the type strong acid and strong base. Salt which is formed from strong acid and strong base, or strong acid weak base, or weak acid strong base, or weak acid weak base. We will take examples of all this. Now take the example of NaCl over here. Take the example of strong acid weak base. Take the example of ammonium chloride over here. Now weak acid strong base. Weak acid strong bases. Take the example of CH3COONA. Weak acid and weak base. Take the example of CH3COONH4. This is minus, this is plus, minus, plus, plus, minus, and minus, plus. Now see, how can you say that this is a salt of strong acid and strong base? How can you say that this is a salt of strong acid and weak base and these? Now see, in neutralization reaction, what I have shown that whenever neutralization reaction takes place, acid reacts with the base, it forms salt and water. Now to check which type of salt it is, I will carry out reverse reaction. Means I will treat salt with water. Now treat this salt NaCl with water. Now NaCl, treat it with water. Now break this bond, it will break towards chlorine atom. Why? Because chlorine is more electronegative. Sodium is a metal, is a species which gives electrons. Therefore I will get Na plus and Cl minus. Break this bond, it will break towards oxygen. Oxygen is more electronegative. I will get H positive, OH minus. Now see, combine these ions in a reverse manner. OH negative attacks sodium, we get NaOH. H positive will be attacked by chlorine, we get HCl. Means our sodium chloride has been formed from NaOH and HCl. Now see, we know that HCl is a strong acid and NaOH is a strong base. Therefore, it's a salt of strong acid and strong base. Now take the case of ammonium chloride. Ammonium chloride dissociates like this. Ammonium chloride dissociates like this. We get NH4 plus and Cl minus. Treat it with water, reverse reaction. Water means we have to treat it with OH negative, H positive. Now chlorine reacts with H positive, we get HCl, and ammonia reacts with OH negative, we get ammonium hydroxide. Now ammonium hydroxide is not a base from group first and group second, therefore it's a weak base. And this is a strong acid, therefore it's a salt of strong acid and weak base. Now take third case, weak acid and weak base. Weak acid and strong base. Now break this ion, we get, break this salt, we get CH3CO negative and Na positive. Now see, break water, treat with water, break water, we get H positive, OH negative. Now react these, we get NaOH, and here we get acetic acid, CH3COOH. Now this is a weak acid, because these acids are weak acid and this is a strong base. Therefore, this is a salt of weak acid and strong base. Now take example number 4. Dissociate this molecule. we get CH3CO negative plus NH4 plus. Treat with water, OH negative and H positive. We get it from water. Attack over here, we get acetic acid and we get ammonium hydroxide. Now this is a weak base because it is not from group first and group second, and this is a weak acid. Therefore, this is a salt of weak acid and weak base. This is the crux of the topic. How can you check whether a given salt is from weak acid, salt of weak acid, weak base, salt of strong acid, strong base, weak acid, strong base, weak base, strong acid. This is the crux of the topic. You can check it. That's all about neutralization reaction. I think that's all about these acids, bases and salts. There is one lecture remaining, that is types of acids: monobasic acid, dibasic acid, tribasic acid, tetrabasic acid or polybasic acids. In the next lecture we will discuss that, and after that we will start carbon and its compounds for class 10th. This is very important topic because questions are asked. Give two in metric board exam, give two examples of strong acids, strong bases, weak acids, weak bases, and in competitive exams you are given a salt and you have to determine what type of salt it is. Is it a salt of weak acid or strong base, or is it a salt of strong acid and weak base? And in 11th class ionic equilibrium, this is very much required there. Thanks for watching. If you like, then subscribe my channel and press bell icon for future notifications. Thank you.